Okay, today we're going to look at the sets chapter. The first thing we need to do is determine what a set is. A set is a collection of distinct objects called elements of the set. A set can be defined by describing the contents or listing the elements of the set. So some example of sets defined by describing the contents might have the set of all even numbers, set of all books written about travel to Chile. Some examples of sets defined by listing the elements of the set. We have 1, 3, 9, 12. Note the set symbols here. These are definitely something that you'll need to include. And we have red, orange, yellow, green, blue, indigo, violet. Same thing. When dealing with sets, it's important to note that the order in which the elements in a set are listed is not important. The set 1, 2, 3, 4 is equivalent to the set 3, 1, 2, 4. Okay, so let's look at some notations. Commonly, we use a variable to represent a set to make it easy to refer to that set later. Then we have this symbol here. Looks like a rounded off capital E. An epsilon means is an element of. And then the same symbol with a line through it means is not an element of. A set that contains no element, which may just be the brackets like this, is called an empty set and can also be denoted by this symbol here, which looks like an O with a line through it. So let's look at some things. Let A equal the set containing 1, 2, 3, 4. Right 2 is an element of this set. So 2 is an element of A. B, right 8 is not an element of this set in mathematical notation. So 8 is not an element of A. Okay, an example of an empty set. Well, what would be an example of an empty set? How about days of the week that do not end in Y? That would be an empty set, right? So a subset of a set A is another set that contains only elements from the set A, but may not contain all the elements of A. It can, but it may not. If B is a subset of A, then we write B is a subset of A, this symbol here. A proper subset is a subset that is not identical to the original set. A proper subset contains fewer elements than the original set. If B is a proper subset of A, we write B and we use this symbol. Now, a way to remember this is thinking about the number of elements in the set. Well, if B is a subset of A, so B has less than or equal to the number of elements that A has. So that kind of sees you have the line there, just like the less than equal. And in this case, if it's a proper subset, then B has fewer than A members in it. That's just one way to remember which notation to use. So let's see what we have here. Consider these three sets. A is the set of all even integers. B is the set 2, 4, 6. And C is the set 2, 3, 4, 6. Is B a subset of A? So is every element in B in A? Yes, every element in B is an even integer. So that is yes. Is B a proper subset of A? Well, B does not contain every even integer, which means that it has, yes, it is a subset of A. Is B a subset of B or C? See, we have 2, 4, and 6, so yes. And is C a subset of A? No, because 3 is not an even integer. Example 4, let A equal the set of all even integers. Is a set containing 2 a subset of A? Yes, it is. 2 is an even integer. Is the empty set a subset of A? Now, here's something that seems like you would wonder about. The empty set. What element is in the empty set? There's no elements in the empty set. So is every element in the empty set in A? Well, there's no elements. So yes, the empty set is a subset of every set. Okay, let's talk about a couple concepts here. We have the union of two sets contains all the elements contained in either set or both sets. The union is denoted by A union B, and look at this, this looks kind of like a U. Or more formally, X is an element of A union B if X is an element of A, or X is an element of B, or both. So it's in A, it's in B, or it's in both of them. The intersection of two sets contains only the elements that are in both sets. The intersection is denoted by A intersect B. Now this is the upside down U. Or more formally, X is an element of A intersect B if X is an element of A and X is an element of B. The complement of a set A contains everything that is not in the set A. The complement is notated in these ways. Another way that I've seen is with a line over it. I don't remember how it's done in the homework. I believe this is used in any test. We'll look at that closer later on. So, if A is red, green, blue, and B is red, yellow, orange, and C is red, orange, yellow, green, blue, purple, find A union B. Well, that would be everything in A. Red, actually, red, green, blue, and everything in B, we've already got red, so yellow, orange, and that's it. Find A intersect B, okay? So red is in A and red is in B, so that's in the intersection. Green is not in B, blue is not in B, so that is it. Now, find A complement intersect C. So essentially, this would be everything in C that's not in A. So let's run through the elements of C. Red is in A, orange is not, yellow is not, green is, blue is, and purple is not. And then A union C, well, again, list everything in A. Red, green, blue, and then list everything in C that we haven't already listed. We've listed it red, we haven't listed orange, we haven't listed yellow, we have green and blue, and we haven't listed purple. Okay, example 6. Let A equal the set of all even integers and B equal the set of all odd integers. What is A union B? That would be simply all integers. The even integers and the odd integers would be all of them. And what is A intersect B? Well, that would be the empty set, not 0. And that is a good point to mention this. This is not the empty set. This or this is. So be careful with that. I've seen that mistake a lot. So now we get to the universal set. A universal set is a set that contains all the elements we are interested in. This would have to be defined by the context. A complement of a set is relative to the universal set. So A complement contains all the elements in the universal set that are not in A. So suppose the universal set is all whole numbers from 1 to 9. If A is the set containing 1, 2, 4, then find A complement. Well, A complement is equal to, run through our whole numbers 1 through 9. A has 1, A has 2, doesn't have 3, has 4, doesn't have 5, 6, 7, 8, or 9. So that would be A complement. Okay. Let H equal the set containing cat, dog, rabbit, mouse. F equal dog, cat, duck, pig, rabbit. And W be dog, rabbit, deer, frog, mouse. I don't know how that got cut off. So, find H intersect F union with W. Okay. Now this is just like when you did order of operations. We do anything into parentheses first. So we're going to find H intersect F. So H intersect F would be everything in H that's also in F. So is cat in F? No. Is dog in F? Yes. Is rabbit in F? Yes. Is mouse in F? No. And now I want to union that with W. So essentially list dog and rabbit. And then list everything in W that we haven't already listed. So we have duck, deer, and frog. And that's it. Okay, and B, we're going to find H intersects F union W. So F union W is everything in F and everything in W. So we have F as dog, cow, duck, pig, and rabbit. And then everything in W, we've already got duck, we've already got rabbit, we need deer, frog, and mouse. And we want to intersect that with H. So is cat in there? No. Dog is in there? Yes. Rabbit is in there? Yes. And mouse. So that would be B. Okay. C. We have H intersect F. We'll take the complement of that and intersect it with W. So H intersect F is equal to what? H has cat, F does not. H has dog, F does too. H has rabbit. Guess we have that right there, don't we? Right here. Okay, now we want everything else that intersects with W. So essentially, anything in W that's not here. So we're looking at duck. Rabbit's in there, so we go to deer, frog, and mouse. So that's that answer. These can get tedious, but they're not really difficult. Okay, so a Venn diagram represents each set by a circle, usually drawn inside of a containing box representing the universal circle. Overlapping areas include elements common to both sets. So we've got two sets here. Now let's draw three Venn diagrams. Okay, this is union or universal set A, B, universal A, B, universal A, B. First we want A union B. So that is, and let's do this. Let's go yellow. A union B is going to be everything in A, everything in B, everything in both. That's that. Okay, next we want A intersect B. And that would be this center area here. And next we want A complement intersect B. So that means everything not in A that intersects with B. So we're looking here. We don't include the intersection there. And that would be that. Okay, use a Venn diagram to illustrate A intersect B complement intersect C. That's our universal. We have A, we have B, we have C. So let's look at this. A intersect B. That's the center area here. The complement of that is everything but that intersection. All right? So we're talking here. We're talking here, 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 and all this out here. But where does that intersect with C? So that would simply be here. So that area there is A intersect B complement intersect C. Okay, the next concept is cardinality. Cardinality. The number of elements in a set is the cardinality of that set. Cardinality of the set A is notated in two different ways. Might be what looks like absolute value of A, or we could have N of A. We have some rules and properties to help us out here. Cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. Cardinality of A complement is the cardinality of the universal set minus the cardinality of A. So, given set A, which is 1, 2, 3, 4, 5, 6, and B, which is 2, 4, 6, 8, what is the cardinality of B? Cardinality of B is equal to 4. All right, 4 elements. What is the cardinality of A union B? Well, let's cheat here, because we can use this, but we're going to need this, which is C. So let's see what the cardinality of A intersect B is. So what is A intersect B? Well, that's simply 1 is not in B, 2 is. 3 is not in B, 4 is. 5 is not in B, 6 is. So the cardinality of A intersect B is equal to 3. 3 elements. So now the cardinality of A, we'll need that as well, is equal to 6. So the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersect B, which is equal to 6 plus 4 minus 3, which is 7. Now, if you're not sure, let's look at it. What is A union B? A union B is simply 1, 2, 3, 4, 5, 6, and 8. And as you can see, 1, 2, 3, 4, 5, 6, 7, which is what we have. Okay, so let's look at something here. A survey asked 200 people, what beverage do you drink in the morning? And offers choices. Coffee only, tea only, both coffee and tea. Suppose 20 report tea only, 80 report coffee only, and 40 report both. Construct a Venn diagram to find out how many people drink tea in the morning, how many people drink neither tea or coffee. So we got a Venn diagram. Our universal set, we have tea drinkers and coffee drinkers. Okay, it says 20 report tea only. Now this is tea only. 80 report coffee only. So that's coffee only. 40 report both. Well, that's the intersection. Now, how many people were surveyed? 200. So how many people do we have accounted for here? We have 20 plus 40 plus 80, which is 140. So that means we have 60 people that drink neither. So what is our question? How many people drink tea in the morning? Well, that's 20 plus 40 equals 60. And neither, well, we have that, is 60 as well. Okay, one more problem. A survey asked buyers whether color, size, or brand influence their choice of cell phone. The results are below. How many people were influenced by brand? So we have 1, 2, 3. And what do we have? Color, size, and brand and universal set. Okay. 5 said only color. Right there. 16 said only brand. 8 said only size. 20 said only color and size. Okay. Only color and size. That's here. That's 20. 42 said only color and brand. That's here. Because it doesn't include, oops, that's the wrong place. Uh, 42 said 42 said only color and brand. Color and brand, that's here. 42. 53 said only size and brand. That's here. 102 said all three. That's this little part in the center. And 20 said none of these. So what is our question? The results are below. How many people are influenced by brand? So this is brand. So what do we have? We have 102 plus 42 plus 53 plus 16. 144, 197, 213. And that's it for this chapter. You guys have a good day, and I will talk to you next time.